Wait, what? She didn't want to be seen by the camera. She had a ninja call.
And then every time you get up, right after class, I had to shut off the camera and see you.
Oh. I forgot about that.
You ready? Okay, what this chapter is about is we're going to start talking about more in detail about the atom, really the history of the atom, how people kind of started discovering each additional thing, because right off the bat, do you think they knew what the atom was made up of?
No.
I didn't know that it made up of protons, electrons, neutrons, didn't know any of that stuff. They started to discover it over time. We're going to talk about those discoveries. We're also going to spend a lot of time with the periodic table this chapter.
Yay.
So, if you're dating, break up with your boyfriend or girlfriend now, because you've got a new one. It's right here.
Well, good thing.
Okay? You will have to memorize about 22 elements, which is not a ton. And then when you take chemistry, it's about 52 that you have to memorize.
I can't wait till that class.
You don't, guys, you just have to know the symbol in the name. You don't have to memorize all the numbers. Yeah, that would be difficult. I had a student memorize the whole periodic table's elements and names. It's actually laminated back there, in a little plastic. Yeah, I told her, I was like, I'll give you 10 points of extra credit to anybody who does the whole periodic table. And she took me up on it. I didn't think anybody would take me up on it. I was like, just kind of, joking. Because I don't give extra credit very easily, obviously. And she's like, can I take this? I was like, well, I guess I said it, so I guess I gotta be a man of my word. And I gave her 10 points of extra credit for it. Alright, here we go. Atomic Model. It's chapter 16. I know, it's kind of crazy. We're doing a hop, skip, and a jump, and a bungee cord fling away.
Hop, skip, and a really long car ride.
Is the car ride, are you hopping and skipping into the car and then going on a car ride? Or are you
hopping
skipping
into the car and skipping out of the car.
That would hurt.
It's like a really bad.
Alright, Atomic Model. Ooh, that's really hard to see, isn't it?
The model of the atom.
You're just writing the same thing over and over again. Alright, so, anybody tell me what a model is? Don't say a really good looking girl. That's what I've had students say before. What's a scientific model? Yeah. Okay. Anybody else have anything else to add? Okay. Anybody else have anything else to add? It doesn't always have to be a visual representation. Did you know that all math equations are models? Those math equations model something. Like Pythagorean theorem. That's a model. Newton's second law. It's a model. Okay? So what a model is simplifying a complex phenomenon. It could be a mathematical, visual, you name it, representation of a complex idea, simplifying it to make it a little bit easier for us to understand. So, for example, can we see the atom? Can you look and see what an atom looks like? No, but we use the model, right? To it's an inside joke with some of my other students.
Guys, someday we're going to be the ones that think of the answer.
Yeah, right? Now we cannot see the atom, and therefore scientists had to do experiments. Is something wrong?
Cannot find the model.
You're what?
My phone.
Oh.
Did you leave it in Mrs. Wilson?
No, I'm gonna let it put on another disc while watching it. How did that get over there?
Hop, skipping, and jumping, car ride.
Okay, so did you hide it?
I did not, but I knew who did. I know who did.
Why?
You just hop, skip, and jump in the car right away. No big deal. Okay, so what you're gonna find with all models is they're believed to be true, right? We can't know without a shadow of a doubt that these things are 100% accurate. Because first of all, you can't see the atom. So what people did is they started doing a whole bunch of experimenting, and based on the information they saw or they got, they deduced what they believed to be going on at a subatomic level. So all of our models are due to experimental data that we've processed and we've come up with, and we really drew a picture of what it would look like that would support what the data says. So each experimental model needs to fit with what we see and what our mathematical data tells us. Okay? So this is a great way of defining models. A simple working representation of a complex phenomenon. All right, so let me explain how this is going to work. Stop, don't write. You're going to see this slide come up like 8 more times. Okay? We're going to talk about the people that were influential in discovering the atom. And so you're going to see A, Leucippus, and then we're going to talk about Leucippus. And then it's going to come back to the screen and say B, somebody else. And then we're going to talk about that person. And then it's going to come back to this and it'll say C, somebody else. Okay, so however you want to do this, if you want to leave yourself some space so that you have all of it in one and then slowly add them as you go along, or if you want to just do the name and then talk about them and then get the next name and talk about them. Does that make sense, what I'm trying to say?
How many names would it be?
It will be, let's find out, a lot, like 8.
That's a long time.
8. Okay.
Lucy.
Wait,
You have a
can we
vocab
just-
sheet for us?
Oh yeah, I do.
Can we just go back to the slide where all the names are there?
You just want to put it in right now?
Yeah, I'm gonna put it all.
You guys want to do that now?
No. Yes.
It's up to you. If you want to put them all in now.
Can we just abbreviate the atomic model with Sam?
Sure. You can abbreviate however you want. While you guys are deciding if you want to put all of them in or not right now, that's up to you. I'll give you your vocab sheets. Vocab sheets looks a little bit different here. Still got about 2 points worth of extra credit you can get. But I have put the models on here.
Yay. Oh, I just started to do this type for my notes, and now it will work.
Oh, no.
Okay, can I explain what I want out of this vocab sheet for extra credit purposes? Okay? The vocab words, listen, you want to pay attention to this. The vocab words are done the exact same way. Okay? When you're doing trying to get the extra credit. The models, here's how these are done. I just want you to give the person what he's believed for discovering, what's important about him, and I want you to write his model, draw a picture of it. Because you're not putting it in a sentence. Okay, you're not doing any sentence stuff. It's just guy, what he's known for discovering, what his model was called, and what its model looks like. Okay? Yes?
About the invisible
Indivisible?
No, I thought it was.
You
I
can't
thought
provide
it was-
some
It's not invisible, guys!
The from living model.
Okay? And I may forget to draw a picture of some of these guys. So if I didn't draw a picture of the model, you'll find it in your book. Okay, so Leucippus was the first guy that really started kind of talking about the atom. And he did really very little for us, to be honest. Except for get the ball rolling. Leucippus was one of the two Greek guys we're going to talk about. Now, what's really important is that, I believe this will come up later, the Greeks did no experimentation. Okay? They never experimented this. If you remember, if you maybe have heard this from other classes or just from people at some point, Greeks were really known more for philosophical things than anything. They were like all the Greek philosophers. You guys probably are familiar with a lot of the Greek philosophers, Aristotle, things like that. Okay? These guys didn't do any experiments. They just started thinking, there must be a smallest thing. I mean, duh, right? But it kind of got the ball rolling that people started to catch on and think, oh, there's probably a smallest thing. Let's see if we can like do some experiments later on to figure out what that smallest thing is. Okay? But what's really important about the two Greek guys we're going to talk about is they didn't do any experimentation. There's really no science involved in what they just came up with. Okay? He believed that the smallest particle was indivisible, not invisible. Okay, what does indivisible mean? Unable to be separated. So we know that the atom can be separated into smaller things. What are those smaller things? Electrons, protons, and neutrons, okay? So he wasn't right, but he got the ball rolling. So here's what his atomic model looks like. Solid sphere, okay? So if you want to draw a picture on your vocab sheet or in your notes, just a solid spherical looking thing. Okay, and next came Mr. Democritus. Democritus was actually a student of Leucippus. So, you know, when you guys graduate and go discover something crazy, you can name it after me if you want, you know. The Kramer principle. How to measure length in expo markers. Yeah.
You have your own coffee brand called Kramer's.
Kramer's Creamer?
Yeah.
Ice cream.
Ice creamer.
Now, his atomic model is really no different from, well, it was actually called the same. So it's a little different. We'll talk about the difference. What's interesting about this is he doesn't have a whole lot of different stuff that Leucippus didn't already talk about. But what's funny is we give credit to Democritus as being the first guy to coin the term atom, even though Leucippus was kind of like technically the first guy. Maybe he didn't like give it a name, but didn't he say there was a smallest particle? Yeah, he said there was a smallest particle. He just maybe didn't give it a name. But guess who gets all the credit for coming up with the name or the term atom? Democritus. He just essentially took what Leucippus said and gave it a name. And he's the one that's getting all the praise for, hey, this guy came up with the name, the atom, when really he didn't do any experimenting either. So really, the word atom comes from I think it's Greek, it might be Latin. Atomos, which means indivisible, which is kind of funny, because we know the atom is divisible. A little ironic, don't you think? No, not ironic? Okay.
It's
Go on.
ironic. Oh, I get it.
Verbal.
An iron atom.
What'd you say?
It's verbal iron.
Verbal irony.
Get it? Iron
Iron. Yeah, that doesn't
atom. Iron
work.
atom.
Now notice his model name is the exact same model name as Leucippus, which kind of makes sense because one was a student of the other, so one would have influenced the other pretty extremely. Biggest takeaway from Leucippus and Democritus. Okay, I don't want to say too much until you guys are ready here. It's annoying, I know. Sorry. Biggest takeaway, Democritus and Leucippus. Leucippus was the teacher, Democritus was the student. They were both Greek guys. They both didn't do any experimentation. That's important, and that'll be, I think that's in your vocab sheet. Alright? The only difference really is that Democritus gave what Leucippus said, gave it a what? A name, and the name was atom, or atomos, which means, what eventually we called atom. Okay, and he believed that all atoms made up all matter, which that's true. Atoms really are kind of the fundamental building block for which all matter is associated with. Here's his model.
Okay, which is a bit more complicated.
Try your best to draw
Or
that.
you just shove it with a fishing line.
He believed, well, okay, so he thought that atoms make up, right? Atoms are really small things, and they have to make up everything that we have, right? So this desk is made up of atoms. Well, how in the world do atoms hold on to other atoms? With fish hooks. Isn't that funny?
Bunch of hooks.
All right, first of all, I want to throw that on my fishing rod and see if I can catch a fish.
Yeah. Shark will bottom that sucker.
What did she say?
A shark will bottom that sucker.
That looks like a
We can
parasite.
kill it though.
That would like,
Ow.
Yeah, that would probably be a really awful hook.
You like to wear a glove, I'm chucking at somebody.
I don't know.
I'll have to show this to Mach.
The world's first.
Hey, don't be crazy in drawing this. Just.
I'm not even gonna try to draw.
Okay.
Just a
Alright,
circle.
we're moving on. Oops. Okay. So he was right. Democritus was right that there was a basic unit of matter, which he called the atom. Here's what he was wrong about. He was wrong that the atom was indivisible. And atoms haven't always existed, right? There was eventually a very beginning part of all atoms, which we believe, at least we should believe, that the start of the atom was when God spoke it into existence. Yep. Oh, that was a hand. When I get to heaven, I want to have God reenact.
I want
Not reenact, but maybe he took movie.
What is that one?
I don't know. Wouldn't it be sweet to see God actually
Heavenly
creating?
popcorn.
Did it just poof immediately was there, or was it some crazy? Yeah, it's here it is in Apple. I've always wanted to know that. Or when he was making Eve, you see this miraculous dust, or making Adam this miraculous dust, is forming this, slowly forming this human being, and wow!
Would that be in PG?
Well, you'd have to have some little censors, I'm sure. Well, I mean, when we get into heaven, I don't think it'll matter.
We'll wear golden robes or not.
Okay? I'm not going to elaborate on this anymore, other than the fact that he was right, that it was the most basic building block of all matter. We call it the atom. But he was wrong about a couple things, and that's what he was wrong about. Whoopsie. here's what I was kind of getting at when I said they didn't do any experimentation. So here, I do want you to get this in. He didn't do, him and Lucebus didn't do any experimenting. All they did was they sat in their togas and they just thought. I don't really know if they were sleeping in their togas, but isn't that kind of like the stereotype of Greek philosophical people?
Sit on a beanbag and think about life.
Beanbag.
Yeah.
That sounds like my life. What is it, more of a couch?
Turn on the level lamp.
Yeah. No, I my cousin was spending the night, we were sleeping on the floor, and all of a sudden I just wake up and go. I look outside and it's just flying. Oh, in 8th grade, my garage is like.
We don't have time to talk about
It
this.
was beautiful.
Okay, did we get this in? I'm not going to elaborate. I already talked about the fact that they did no experimentation, all that, so we can move on, right? Did you get it, Everett? What did Democritus do?
Coin the atom.
Okay, is that an option up here?
No.
Theorize.
Ah, he didn't discover, did he?
No,
He
that
just,
was-
remember, he didn't do any experimentation. Okay, Democritus was right when he said, I ain't giving enough time, you don't have a ton of time, so. All right, Mr. Dalton, Mr. John Dalton, the English school teacher. Dalton, John Dalton. Oh, it's more than I want. Oh, yes.
Just finish off.
So, this is the guy who was the first to start doing experimenting. He did a lot of really cool stuff. We're not going to talk about all of it. But essentially what he did is he started taking objects and started weighing them, and then he would break them up into their individual atoms. Like, for example, he took water, which is made up of 2 hydrogens and 1 oxygen. He weighed the the amount of water, and then he broke apart the water into hydrogen and oxygen and reweighed the hydrogens and the oxygens. That's for another day.
But that was like not possible. Well, like not possible, but like.
It's not easy, but
Yeah.
yeah, we do it all the time now. And what he noticed is that every time, no matter how much water he broke apart, the mass of the hydrogen in comparison to the mass of the oxygen, when he weighed them, was the same ratio every single time. That was a pretty big finding back then. Big deal. Because they didn't really know what to make of all of these things. They could just see water and they're like, okay, what's that made up of? Okay, it allowed them to finally start putting the pieces together that every water molecule has 2 hydrogens and 1 oxygen. Every single time. If it changed, it would be something different. Like if all of a sudden water got another oxygen, it would be hydrogen peroxide. That's different. I don't think that's possible actually.
Oh.
To be stable.
Oh.
All right.
I didn't get the.
So here's subtly another guy who kind of came up with a law of definite proportions, which is what Dalton was using to try to kind of come up with these relative masses. And I'll explain this in a sec. Here's what we're going to do. We're going to finish this. You still should be able to answer your questions and do your homework. And if you get something where you don't know, you should be able to read and find just fine. We will finish the rest of the notes tomorrow and progress on. Okay, but you sure shouldn't have any difficulty with coming up with the answers to your questions by reading. And I want to take a little bit more time going over Dalton. Dalton was kind of important. Cool, so come across something you can't answer, make sure you read, you'll be able to find it. Cool? Ah,
We only have one question.
what?
We only have one question.
I think there was like 4, wasn't there?
There's 4.